want to work through one more identity together, and then I'm going to give you folks one to try. So again, I've selected an even numbered problem from the book. So here's my left-hand side, and I want to prove that it equals the right-hand side. And I wanted to look at this because I'm going to do something that's not immediately obvious, okay? I'm seeing here on the bottom, I've got sine x minus cosine x, nothing squared. Here, in this denominator, I've got some cosines squared. What I'm going to do is I'm going to start with this left-hand side. So that's sine x plus cosine x over sine x minus cosine x. And I'm going to multiply that by 1 in a very specific form. I'm always allowed to multiply by 1. That changes the way things look without changing their value. I'm going to multiply by 1 in the form of the conjugate of this denominator. Same two terms, but with the opposite sign. So sine x plus cosine of x. Now, that happens to be what I have on top here. That wasn't my reason for choosing that. I was choosing that because this was the difference of two terms. I'm going to multiply by the sum of those same two terms. But of course, I've got to make sure that I'm multiplying by 1. So it's got to be the same thing on top and on bottom. Now, the reason I'm doing that is because now I'm going to get on the bottom a difference of two squares. Because I'm going to get, when I FOIL, my first terms give me sine squared x. My outsides and insides are going to cancel, and then I get a minus cosine squared x. So that's a way of going from a denominator that doesn't have any squared terms to a new denominator that does have some squared terms. And that difference of squares is often very, very useful. Okay? So it's not something super obvious, which is why I wanted to do this example together to point out that sometimes that's what you want to do if you want to go from something without squares to something with squares. Let's see what I have on the top now. Okay, I'm going to have to FOIL out the top, so that's going to be sine squared x. Outsides are going to be sine x cosine x, plus insides are cosine x sine x. That's just two copies of the same thing. So plus 2 copies of sine x times cosine x, plus my last terms will be cosine squared x. Okay, looking at where I'm going, I see my 2 sine x cosine x. Oh, and I see my 1. Because the Pythagorean identity tells me that sine squared x plus cosine squared x is equal to 1. Okay? And with addition, the order doesn't matter. So I can group those. I'm going to actually show that in a separate step. That's sine squared x plus cosine squared x plus 2 copies of sine x cosine x all over sine squared x minus cosine squared x. But then I've got just, that's 1 plus 2 sine x cosine x over sine squared x minus cosine squared x. Okay, so let's see. I can either keep going or I can work with the right-hand side. I think I'm actually going to keep going. So let me just copy up here since I've run out of space. We've gotten to 1 plus 2. So this was the left-hand side. It equaled 1 plus 2 sine x cosine x over sine squared x minus cosine squared x. Okay. And while I don't yet know that it's equal to this, I know that's what I'm trying to prove. So I can sort of look here and say, I want to change that denominator. I don't want to have any signs. Okay. But a little bit of side work here. And this may be side work that you're comfortable just doing mentally and don't need to write down, and that would be fine. I know that my Pythagorean identity is sine squared x plus cosine squared x equals 1. That means that sine squared x is 1 minus cosine squared x. So I can get rid of these sine squareds. So I can say this is 1 plus 2 sine x cosine x over sine squared, we just said, is 1 minus cosine squared x, minus cosine squared x. Nice. Now if I combine my like terms, That's going to be 1 plus 2 sine x cosine x over 1 minus 2 cosine squared x, which is the right-hand side. So we were able to prove this one. Okay. Now, a lot of times when people are working with identities, it feels intimidating because you look at this and you're like, I don't see why it equals that. I don't expect you to see why it equals that. That's why we do the proof. That's why we work through it step by step, and you're just taking small steps. So you just need to be able to find a way of changing the way something looks, usually trying to make it simpler. Here, we actually made this side a little bit more complicated because we wanted to get to a denominator that had some squares. I could have also started with this side and tried to work my way to this side. I chose to start here, but that trick of if you have just a sum of two terms or just a difference of two terms. If you have a sum and you multiply by the difference of those two terms, or if you have a difference and you multiply by the sum of those two terms, you're going to get a difference of squares. And so that was why it was useful in this case to multiply by 1 in the form of sine x plus cosine x over itself. Okay, so I am going to have you folks try one, and these are kind of time consuming, so I've chosen one from the homework so that we're killing two birds with one stone. You're getting some practice in these video lectures, but you're also getting a jump start on the homework. So this is problem number 45. Okay. 1 over 1 plus secant of x minus 1 over 1 minus secant of x is going to equal 2 cotangent of x times cosecant of x. So see if you can prove that. We're going to go through it together in the next video. As you're watching the next video, if what I do doesn't match what you did, but you think you have a legitimate proof, you very well might. Proof writing is like the essay writing of math. So if I were to say, write an essay about how you feel about the pandemic, there's no one right answer. There are lots of really good essays that people could write. Okay? There are lots of ways to prove this. Okay? So we will go over it in the next video, and I will show you a way of proving it. If it doesn't match what you did, but you think your proof is legitimate, if you're confident, great. If you're not sure, feel free to double check with me. You're welcome to email it to me or come to office hours and share the screen with me so that I can take a look at your work and see what you did and just confirm that you did it correctly, or if you didn't, point out where you went wrong. Okay.